Morning, everybody. Today we're going to start our last chapter, chapter 11, which is on radical expressions. Couple things I want to go over before I get started on your actual notes. This is a topic that is a little bit easier for me to explain in class when we have a lot of time. What I want to do is go over what radical symbols mean, what those numbers are, and why they're useful for you to know. The first thing that I want to go over is a radical symbol is also the square root symbol. So for example, if I gave you this, I would call that radical 50. You can also think about it as what is the square root of 50. More often than not, radical symbols are used to express numbers that are irrational. They're numbers that as a decimal go on for forever. Sometimes it's better to use the radical symbol because it's a very exact way of measuring it. If you put this into your calculator, you get a decimal and you could round it. So for example, let's actually use this as a square root using the word square. Let's say that I wanted to make a garden box or a pen for animals that was 50 square feet. So I want the area of this to be 50 feet squared. The problem is no number multiplied by itself makes 50 for this to be a perfect square with whole number sides. The best thing I can do is in my calculator take the square root of 50. Now, when I find the square root of 50, I get a decimal that goes on forever. It's like 7.07106781119, and it keeps going. So I could technically, if I didn't need this to be an exact perfect square, I could write this as 7.1 times 7.1, which would get me pretty close to the square that I need. If I did it that way, I would actually get a final area of 50.41, which would round down to 50 square feet. That's an example of sometimes the decimal's okay because you don't need it to be an exact measurement. One place where a radical is going to be important is, let's say that radical 50 represents a very specific amount of fuel that a rocket needs, or maybe you're talking about electricity where you need that number to be exact, then it might be better to keep this as a radical symbol. But because 50 is so big, there's ways that we can simplify that number so that I can combine it and have it work with other numbers because I can make these things have something in common. One place that you might end up using this, depending on what kind of field you go into just right off the way, if you go into anything with being an electrical engineer, or really any kind of engineer, whether you're working with computers, electricity, actual physics, one common thing is, for example, if you wanted to find the voltage of something, the voltage is if you take the if you do radical PR, P standing for power, and R standing for power in watts, and R is standing for the resistance, because again, in electricity, you can't always have a perfect current. If you're figuring out the volts of something and you need to figure out if you have enough power to make something or have something work, you want something more specific. If you're making a square area in your yard and you just know you want it to be 50, and you can kind of work with a number and round it, that's fine. Sometimes you need something more exact. So that's an example of where we're going with this. Keep in mind, radical symbols around numbers are more often than not just representing a number that is going to be an irregular decimal that just goes on, an irrational number that goes on for forever. Here, I have a couple of notes for you. These problems are going to go very quickly. The thing that I want you to keep in mind are these numbers that I'm writing up top. These numbers, and sorry my hand's covering it, these are all your perfect square numbers. These are the numbers that you get when you multiply a number by itself. So 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. I'm not going to expect you to memorize these, but they're going to be really helpful for you to know on your homework and for pretty much this entire chapter. I'm going to try to only give you the ones that you need. I don't think you'll have anything bigger than 144 for a perfect square, but just in case, 13 times 13 is 169. These blue numbers are going to be the numbers that you're looking to use in these problems today. I'm going to try to do this kind of quickly, just because I don't want this video to take too long. Simplify each radical expression using the perfect square. I can take this radical number and simplify it where I can create it in a different way, where if I put it in my calculator, I would still get the same decimal number, but it might be easier for me to combine with other numbers I have to work with, especially if I'm plugging this into an equation where I have to add or subtract a lot of irrational numbers together. So if I break this down as radical 12, I'm looking for a perfect square that goes into this. I can think about radical 12 as radical 4 goes into 12 if you just think about regular division. I can divide 12 by 4. The other number would be 3. If you notice, I'm kind of making one of those, like, it's like a common factor tree or a multiples tree that you probably did in 5th or 6th grade. It's similar to that, but with a radical symbol. If you notice, radical 4 is a perfect square. This is 2 times 2 exactly. Radical 3, if I put it into my calculator, I'm going to get an irrational number that goes on for forever. This changes to just be 2. So I can rewrite radical 12 as the whole number 2, radical 3. The reason that I might want to do this is, let's say that I need to combine this with a couple other numbers that are also irrational. I might be able to break them down where I can combine them with this smaller 3 and this 2 that they have in common, because most numbers are going to be able to be divided by that. What I'm also going to be able to do with this later on is, if this doesn't work out perfectly in every problem, I'm going to show you how you can combine these things instead of needing to use decimals that go on for forever. Again, the reason you use this instead of the decimal number is simply because sometimes we need to be very, very exact. And keeping things like this, it's going to be very exact. This next one, 45, the perfect square that goes into that, and by the way, you want the largest number. On some of these, like 4 can go into it, but 16 can also go into it. You want to choose the largest one. If you don't, it kind of becomes a headache. I'm going to call that radical 9 and radical 5. If in your calculator you put radical 5, you're going to get a decimal that goes on for forever. 9 becomes just the number 3, because 3 times 3 makes 9. So my answer is 3, radical 5, and I'm finished. Next one, 32. 4 can go into 32, but 16 can as well. You want to go with the largest one, because if not, you're going to have a bunch of numbers that break down, and it's going to get kind of confusing how to combine them. I would write this as 16, radical 16, radical 2. Radical 2 is an irrational number. 16 breaks down to 4 perfectly, so my answer is going to be 4 radical 2. If you notice this isn't taking a lot of work, I am expecting you to show your work at least today, with things being multiple choice. Next one is the square root of 60. I would break that down as radical 4 and radical 15. If you notice the pattern here, one of these numbers is going to be a perfect square, and the other one isn't going to be, and it's just going to stay. 15 would break down to 3 and 5, and neither one of those are perfect squares, so I can't break it down farther. Next one, 98, that's going to be 49 and 2. And by the way, I'm expecting you to use a calculator on this. I am not expecting you to be able to figure out some of these in your head. If you need to have a calculator next to you, by all means, please just make sure you're showing your work. I want to make sure you understand the process that I'm doing. One more time, the reason that this just becomes a regular whole number is because if I put radical 49 in my calculator, it becomes the whole number 7. So there's no reason for me to keep it as this. I can just break it down and put it up front. This technically means multiply, and we're going to get more into how these two work together and with other things later on. Today, I just want to focus on simplifying these. Next one, 63. That's going to be radical 9, radical 7. If you also notice, most of the time, the first multiple set that you come across is going to be the one that works for you. This one's an example. 4 works, 25 works, and 100 works. If you're not sure which one to use, what I do is start with the list, and I work backwards from the biggest number to the smallest and find the first one that works. That's the one you want to use. 102. 2 is going to stay irrational. This is going to change down to just a perfect 10 times 10 makes 100, so 10 radical 2. Next one, again, I'm going to do this just kind of quickly to save some time. We're going to spend at least 2 days on simplifying these, so if I'm going a little fast and you're confused, that's okay. We're going to spend more time on it. It's going to be 36 and 15, so that's going to be 6 radical 15. How am I doing on time? 10 minutes. Okay. What I think I'm going to do is, for the sake of time, I'm going to break this into 2-part videos. just because I want to make sure that you understand it and I'm not rushing. But I can't upload a video that's longer than 15 minutes. So I'm going to take a break here, and then there's going to be a part 2 for the bottom section.